Assalamualaikum and hi everyone. Okay, so this is mass spectrometer. Mass spectrometer is an analytical technique that measures the mass of charge ratio of ions. A mass spectrometer is used to determine the relative atomic mass and the relative molecular mass. Okay, so it can also be used to determine the type of isotope, the abundance, and the relative isotopic mass. Alright, the result that are presented as the mass spectrum, a plot of intensity as a function of the mass to charge ratio. Okay, so this is the sample of mass spectrum for chlorine. Okay, what are the information that we can get from the mass spectrum? Okay, so as we can see clearly here, we have two peaks. Okay, so meaning that chlorine have two isotopes. So how that we can label these two isotopes is referring to the mass to charge ratio. So we label it as chlorine 35 and chlorine 37. Alright, so next information is about its abundance. Okay, so abundance here means how many percent that the chlorine exists naturally. Okay, so since chlorine 35 has the highest peak, meaning that it has the highest abundance, is about 75.53%. Okay, as for the chlorine 37, okay, the abundance or the percentage abundance is about 24.47%. So how that we can calculate the average atomic mass is by using this formula. Average atomic mass is equal to sum of Qi times Mi over sum of Qi. So what is the meaning by Q and M? Okay, Q is referred to the relative abundance or percentage abundance of an atom of the element, whereas M is referred to the isotopic mass of the element. Here is the sample of question about mass spectrum. Alright, figure 1. This is figure 1, shows the mass spectrum of the element chlorine. Okay, so the first question, what isotopes are present in chlorine? What is the relative abundance of each isotopes? And calculate the relative atomic mass of chlorine. Okay, so we take a look at the sample of calculation. Alright, so now is the sample answer. Okay, sample calculation. Okay, so what isotope are present in chlorine? So look at the mass spectrum. There are two peaks present. So therefore there are two isotopes of chlorine. Now how that we can write the isotope? So how to label? So just refer to the isotopic mass. So we can label the both isotope as chlorine 35 and chlorine 37. Okay, from the mass spectrum is already given to you. The y-axis is referred to the percentage abundance. However, for the second question, what is the relative abundance? So relative abundance here means that in form of ratio. In the question given to you in form of percentage. So we want to convert from ratio to percentage. Here is the sample of the calculation. So it's very simple. We just divide the percentage abundance of chlorine 35 with 100, and you can get the ratio for each of the isotopes. So the ratio here is, we call it relative abundance. Okay, for the third question, okay, calculate the relative atomic mass of chlorine. Okay, relative. Okay, so how that we can solve this problem? Okay, the first step, you can calculate by using the formula of average atomic mass, where Okay, that is sum of QI/MI over sum of QI. Substitute all the values with the unit. Don't forget the unit here. Okay, and we can get the final answer is 35.46 AMU. However, the question asks you to calculate the relative, which means no unit. So we still have unit here, so therefore you have to add second step by using the formula of relative atomic mass is equals to mass of chlorine atom compared with carbon 12. Therefore, we can cancel out the unit. Okay, AMU, and the final answer is 35.46. Okay, next question. Let's take a look at the next question. Okay, a sample of chlorine consists of 76% chlorine 35 and 24% chlorine 37. Okay, question asks you to calculate the relative atomic mass, and already given to you the mass for each isotope. So for chlorine 35, the mass is 34.96 mu. As for chlorine 37, the isotopic mass is 36.97 AMU. Okay, so first of all, you have to take out all the information and label it like this. Okay, next step, we can use the formula of average atomic mass. Alright, remember, start with the formula, then substitution with the unit. Okay, don't forget with the unit. And we can see here, we still have unit at the first stage calculation. So, since question asks to calculate relative with no unit, you have to add the second step, okay, by comparing the average atomic mass of chlorine with carbon 12. Okay, therefore, the final answer here is 35.46. Okay, for the next question, a quite long question here. Analysis using mass spectrometer shows that copper consists of two natural occurring isotopes, copper 63 and copper 65. If the ratio of relative abundance for two isotopes is 2.235. Okay, calculate the percentage relative abundance for each of the copper isotope. Alright, so how that we can solve this kind of problem? Okay, first of all, given to you the fraction of for copper isotope. Okay, from this fraction or from this ratio, we notice that the ratio of copper 63 is 2.235, whereas the ratio of copper 65 is equals to 1. Okay, meaning that we want to convert from ratio to the percentage abundance. So what you can do? Okay, so what you can do here? Okay, so okay, right. So we just take the ratio of copper 63 is divided to the total ratio times 100%, and the answer is 69.09%. Same thing goes to copper 65. Okay, ratio of copper 65 divided with total ratio times 100%. The answer for copper 65 is 30.91. Right, so this is the last question for this topic. Okay, a natural occurring element W composes of two isotopes, W191 and W193. If the relative atomic mass of W is 192.25, determine the percentage abundance of each isotopes. Right, so first of all, we take out all the information given. So for the W191, we had only the information about the isotopic mass. Okay, 191. Okay, based on the nuclear number, as we know that nuclear number is equal to the mass number. Okay, right. So for the W193, also we only have the isotopic mass. So we don't know what is the value of Q. This is what we want to find out. Okay, and already given one more data is the relative atomic mass of W192.25. Okay, how that we can calculate? The first of all, right, so we have to assume the percentage of abundance of W191 is equals to X%. Since we know that the total percentage abundance should be 100%. Therefore, the percentage of abundance of W193, we can assume it as 100 minus X. Alright, so for the second step, you can substitute all the values into the formula of average atomic mass, sum of Qi Mi over sum of Qi, and from here we can find out the percentage of W31 is 37.5%. Okay, next, how that we can calculate for the chlorine, W193, so 100 minus 37.5, and the percentage or abundance of W193 is 62.5. Okay class, that's all for today. Remember, practice makes perfect. Okay, thank you, and we see you again in the next class. Bye.